Welcome everyone! Today we're going to be talking about how to solve limits that have trigonometric functions embedded inside of them. Let's get right to it. Okay, so let's take a look at this limit right here. So we have the limit as theta approaches 0 of cotangent of theta times sine of theta. And as always with these limit problems, let's just plug in the theta value or whatever limit value that we're approaching. So we'll have cotangent of 0, and that is going to be multiplied by sine of 0. Okay, well, sine of 0 we already know to be 0 just from knowing our trig values. And cotangent of 0 we know to be undefined. And right here, this undefined times 0 situation is actually an indeterminate form. So once again, we're going to have to do some algebra to figure out what the limit value actually should be. So this time, let's kind of try to rewrite cotangent with its actual definition. So we'll have the limit as theta, and theta is going to approach 0, of cosine of theta in purple right here, divided by sine with a purple theta here. And then we'll have that sign that we were multiplying originally right here on the right. So that'll be a sine of theta. And well, now we can pretty easily see that this sign in the denominator and the sign in the numerator, I guess that's being multiplied, just kind of cancels really easily. And we're just left with the limit as theta approaches 0 of a very, very simple cosine of theta. And as it turns out, when we just plug in that 0 into cosine now, we end up with cosine of 0, and we very easily know that to just be 1. So as a matter of fact, that becomes our final answer, just that 1 right there. Alright, so in this case we have the limit as theta approaches 0 of 1 plus sine of 2 theta divided by sine of theta. And like always, let's just plug in the limit value to see what we get. So we have 1 plus sine of 2 times the 0 that we're plugging in, so that's our 0 right there. And that is going to be divided by sine of the 0 that we're plugging in. So if you recall, sine of 2 times 0 is sine of 0, which is 0. And we have that sine of 0 again here in the denominator. So we have that 0 divided by 0 situation. Even though there is this plus 1 here, the indeterminate form fraction is what's really important to us. And that's what tells us that we have to do algebra to figure things out. So going back to this limit here, I do recognize this is a very particular form of sine. So if you recall, there's actually a formula for the sine of a double angle. So sine of 2 theta is equal to 2 sine of theta times cosine of theta. So let's actually try to plug in that definition or that identity into our limit and see where it takes us. So we'll be left with the limit as our theta, it'll be approaching 0, and the function that we're taking the limit of is 1 plus now 2 sine of the theta that we're looking at, and that'll be times the cosine of the theta that we're looking at. And that entire term there is going to be divided by just a simple sine of theta. Well, now we can see, well, the sine of theta on the top and the sine of theta on the bottom cancel out very nicely. So that just leaves us with a very simple limit as theta approaches 0 of 1 plus 2 cosine, actually, I won't write that up here, 2 times the cosine of a theta. And well, now we can see it's pretty simple to just evaluate this limit. We can just plug in the 0 into the theta on the cosine. So that leaves us with a 1 plus 2 cosine of the 0 that we're plugging in. Cosine of 0 is 1. 2 times 1 is 1. 2 times 1 is 2, not 1. And 1 plus 2 is 3. Alright, so in this example, we have the limit as theta approaches pi over 2, and that'll be of cosine cubed theta times tangent squared theta plus 1. So, like always, let's just plug in the theta value and see what we get. So we'll have cosine cubed of our theta value times tangent squared of our theta value plus 1. And our theta value happens to be pi over 2 for both of these. So that's what expression we're trying to solve for here. So cosine of pi over 2, that's just going to be 0. And 0 cubed is still 0. So we'll have a 0 times tangent of pi over 2 is undefined. Undefined squared, well, that doesn't really make any sense, but it's still undefined. So that'll be an undefined plus 1. So see here, we have a 0 times undefined. This is really weird, and it's indeterminate form even. So once again, we have to do some kind of algebra to figure out what this problem actually should end up being. As a matter of fact, we can notice here that tangent squared of theta plus 1 is actually the Pythagorean identity for secant squared of theta. So, since these two are just equal, let's write it out that way. So let's try that out. So we will have the limit as our theta approaches, oh, sorry, wrong color there. So it'll be as it approaches pi over 2. So we have that cosine cubed of theta times now the secant squared. And in both of these, we have the theta as our variable. Well, recall that secant is 1 over cosine. So if we have 1 over cosine squared and we multiply by a cosine cubed, well, the way that we combine exponents like that is that it'll be a 3 minus 2 power on the top. So that's actually just very simply the limit as theta, and our theta is going to approach to pi over 2 once again. So the cosine cubed divided by cosine squared just simplifies to a very, very simple cosine of theta. And now we can plug in that pi over 2 into the cosine. And that's really simple. That just becomes cosine of pi over 2. And actually, we evaluated that at the very beginning of this problem. And that ultimately just gave us a 0. All right, that just about wraps everything up. Thank you for watching and have yourself a great day.